Okay, so this third video in the second series part, the intro, forget about the numbers. I will number them. I can't keep track of anything. I just literally come in here, turn the camera on, and ramble about stuff in processing. But, okay, so I forgot a couple things in the previous video that I'm just going to kind of fill in right here. One is, and I think I showed you this in one of the introductory videos about processing, but you should take a note of the fact that processing comes with a huge amount of examples. So I also encourage you when you're beginning to just go through some of these basic examples, particularly form here. You might kind of like, well, this actually has a lot of stuff that we haven't learned yet, but you can kind of get a sense of what's possible to draw in processing. You might find that useful just to kind of poke through a bunch of the examples and kind of see what they do. The other couple things I wanted to mention is that processing, in addition to having that reference that I showed you on the website, you can also here under help, there are various, you can actually, if you're not online, you can actually get the reference. Like if I just click this, it's going to open the reference. The processing downloads with the reference as well. So you can actually, from the development environment itself, from the processing application, you can look up stuff in the reference as well. The last thing that I want to just mention, which is that you might have noticed that text is turning different colors. Like if I by accident delete this E, we can see that the LIN is in black. If I add the E, it's in, oops, I have caps lock on. If I add the E in lowercase, it's in blue. So the processing development environment will color the text that you're writing different colors just as a little way of helping you along to see that you're kind of spelling things right and what's a known word and what's an unknown word. So, but those colors have nothing to do with how your program executes. It's just a visual help to see that you've spelled things wrong. So one thing you might notice, when I run this, it's going to say the function LIN does not exist because it doesn't exist. But the function line does exist in processing, and I would correct that by typing in E. Okay. I guess I'm going to I'm going to keep going now. So back to color. I don't know if this filling stuff in at the beginning of the video was a good idea, but I did it, and I don't know. I can always split it into two later, I guess, if I need to. Okay, so what we've done so far is we've learned about downloading processing, running processing. We understand about a computer graphics window, x-axis, y-axis, where the pixels are. We got a sense of different functions we could use to draw to the window, but what about color? So one thing you'll notice, if we go back and run this program, is that, here I am. You'll notice that the line is black, the rectangle seems to be white, but maybe has a black outline, and then the back of the window itself is just kind of this gray color. So we've never specified a single color for anything. We didn't say draw a red line. We didn't say draw a blue line. We didn't say draw a rectangle with a blue filling, delicious blueberry filling, and like a red outline. Processing just decided to use default colors, which you can see are just black and white because we didn't specify. But now is the moment where we can start to look at how to specify color. Okay, so how do we do that? So one thing we should be aware of is any shape in processing. Take a rectangle, for example. Any shape in processing, for example, a rectangle, it has both an outline, which we should really call a stroke, and it has also, I don't know what to call this, an interior, which we'll call a fill. So fill and stroke are the key words, the function names that set color in processing for the outline and the interior of a shape. Now a line has no fill because a line only has a stroke. But an ellipse or a rectangle has both a stroke, the outline, and the filling. I just decided to say now that creamy filling, cream, that upsets my stomach. So fruit, I like fruit fillings. It's good. Not too much sugar, I don't like it too sweet. But anyway, that's the inside. You didn't need to know all that information. Okay, so how does this work? So let's say we have a program which is drawing a rectangle at 200, 150 with a width of 50 and a height of 35 pixels. So this is our program that we are writing. Let me kind of erase this. How do we set that rectangle's color? the way we set a shape's color is by setting the fill or stroke with the lines of code in advance of saying rectangle. So order of operations really matters. What we're doing is we're almost like the processing program is running and there's like a thing with a pen there and it's like it reads, stroke blue. Oh, quick, let me go get a blue pen, red. I got the red pen and whenever I get to rectangle, I'll draw it with red. And then if it says stroke black, it'll suddenly switch and get the black pen again. So it's reading the code step by step and setting the stroke, setting the fill for whatever that next shape is going to be. So if I were to say stroke, we need some arguments, right? How do we define the arguments for a color? And we need a fill. So that's a big question. So we can see that what we're ultimately going to do is we might say like, hey, I want to have some sort of color stroke for the line and some sort of stroke and some sort of fill for that rectangle, right? I want to give the line a stroke, the rectangle a stroke, and a fill, but what are those arguments? What are those arguments? How do we define color? Okay, I'm asking that question over and over again because I'm kind of trying to avoid the answer because I feel a little uncomfortable trying to explain it, but let me give it a try. So first of all, there are lots of ways to think about color. You might have in some time in your life done finger painting and you have like some primary colors and you could mix them and get other colors. That's a nice way to start thinking, but so that's kind of what we're going to do. But we're not going to use those. I don't. If I had a pause and restart, I would just do that now. But I'm going. We're going to mix colors, but we're going to mix digital color, and digital color follows the properties of light. So we need a little bit of red, some amount of green, and some amount of blue, and all of those together will give us a color. So that's what we're going to do. So we need 3 arguments. This is what's known as RGB color. RGB color. So I got off track because I got confused what I was saying. This is just my rehearsal that I'm going to upload anyway. I want to mention that there are, we're not going to get into all this right now, but processing allows you to define color in many ways. You could define color based on something called hue, saturation, brightness. You could define color with all sorts of different amount of ranges. But what we're going to look at is the default way that color works. It's the best way to get started and kind of just try stuff out. Although I think looking at hue, saturation, brightness is kind of important. That's probably its own video though. So the default way is, again, red, green, and blue. So the ranges for each one of these values is 0 to 255. So if we say 0 red, then that's no red. If we say 255 red, that's a lot of red. Right? So you could imagine, what is this color? 0, 255, 0. If this is, again, RGB color, and we're saying the fill, what would this color be? Well, it's no red, no blue, but all the way, turn that green switch all the way on. So that's a green color, right? So let's go take a look at that and just prove that this works. If I make the interior of this rectangle green and the stroke of the rectangle I'm going to say is red, and I'm going to have the stroke of the line, just so we see all 3 of these, as blue, and we run it again, we can see now, we have a green rectangle with a red outline and a blue line. Why do we have all of that? Because that's what we specified with stroke. 0 red, 0 green, 255 blue, right? So obviously, this is just sort of a very basic beginning of this. And you might start to mix colors and imagine like, okay, well, what does what does green and red make for the fill of that rectangle? Yellow. So I'm a little color challenged, and I always feel like very it gives me a lot of anxiety to pick colors. But I have a feeling that if you found your way here, you're kind of interested in design, maybe you like color, you have some ideas yourself. So what I would say here is this is kind of all I have to say. I have a bunch more things to say actually, but in terms of color, I would encourage you to start playing around. You might have experience using Photoshop or designing websites, and you've done a lot of stuff with color already. Processing actually, by the way, also allows you this is a bit of a digression, but to write your colors this way. So if you've ever done color for the web with this hexadecimal notation, you can also do that directly in processing. But I think I want to focus really primarily on this idea of numbers, red, comma, green, comma, blue. But let me add, since we're only at about 7 minutes, let me add a few more things to this equation. First of all, what if I were to make the fill 255, 255, 255? All the way red, all the way green, all the way blue. What do you think you're going to get? Jeopardy theme music playing, you can run it, we are going to see. We have a white rectangle. Again, remember, this is the properties of light. So if we take all of red, all of green, and all of blue, mix them together, we have white light. If we turn all the lights off, if every one of these values is 0, 0, 0, 0, then we have black. So we only have color in all those sort of areas in between, so to speak. So one thing that I should say, I lost my eraser, here it is that, right, if you want to do white, right, we said it's fill 255, 255, 255, or black 0, 0, 0, processing allows you to do something with a little bit of shorthand. It would be very inconvenient to always have to put all 3 in there. You can actually, if you ever specify color with 1 argument instead of 3, it will assume what you meant to do was use that number for all 3 values. So I can say, give me, come back over here. I can say, I don't know what I'm doing. I need a better layout. My head is in the way, which kind of defeats the purpose of this weird green screen thing, but it was kind of an idea that seemed to make sense. I can say fill 255 instead of 3 255s, right? And get the same result, a white rectangle, which is interesting to note because, by the way, what if I say fill 100? Notice I have a gray color, a dark gray, not black. 0 would be black. It turns out that grayscale color, by the way, any grayscale color is a color where red equals green equals blue. So 100, 100, 100 is a slightly dark gray that we could give a shorthand as just the argument 100. So we can both specify color as a single value for a grayscale color or 3 values for red, green, and blue. 2 more things I want to touch on in this video. Another thing, I feel like a pause for questions is really what I feel like doing right now, but it's a video. And it shouldn't be, but it is. Okay, so the other thing I want to mention is, by the way, there is a function called background, right, which allows me to also set the color for the background. So there is a black background, which I did using a single argument for grayscale, or I could say 0, 255, 0, and here is a green background with that color. So the background function fills in the background of your processing sketch window with a color. Now, the other thing I should just mention, by the way, is I've been kind of using the word program, your application, the processing window, sketch. I'm going to try to now consistently use the word sketch. The word sketch is kind of a word for a processing program. We think of this, your sort of folder of processing programs as your sketchbook, for this idea that processing, one of the things it allows you to do is very quickly sketch out ideas through code. So I'm going to say your processing sketch now has a green background. However, here's something really important. Order of operations is key, right? Just because, what does background actually do? It fills the screen with a single color. Even though we think of the term background as it should put it behind everything, the order that this code executes is quite important. What if I were to put background at the end? What do you think is going to happen? Will it look the same? Clearly no, otherwise why would I be doing this? Look what happens. I don't see my rectangle and line anymore because it drew the line, it drew the rectangle, but then it drew the background on top of it. And this is a real, once we start doing animation, this idea of where the background goes is going to be truly, truly key. Okay, the other thing I should just point out, by the way, is that if I didn't set a stroke for this second rectangle, right, the stroke from, of course I have background at the end, the stroke from the line would carry over, which is very hard for you to see, but I can zoom in. You can see that both the line and the rectangle are blue. That's because, remember, when you set the stroke, it's the stroke value for all shapes that are drawn afterwards, unless you override that stroke with a new value. I should also just sort of point out, look how I'm typing this. The actual, these like extra line breaks and where I put the stroke and fill, none of that really matters. I like sort of putting things in little groups because I have I'm like the anal retentive coder who's like, okay, let me put size and background together and then stroke and line and then stroke, fill, and rect. Like it just, I can read it and it makes sense. But truly none of that matters. In fact, this code would execute exactly the same way, but it's much harder to read because the line breaks don't matter at all. Semicolon is what tells the processing program we've reached the end of a line. I have to put it back the way I had it. So what's important to realize is that the syntax, spaces and line breaks tend to not really matter, right? I can put a lot of spaces here, and it's actually, oops, I put this extra stuff. It's actually going to run exactly the same way. But there often is a way of writing code that feels a little bit more human readable. These should be separate videos, because I want to talk about comments now, but it's okay. Yeah, and I'm going to do a couple more things in this video, because maybe I'll fix these later through some magic way of doing it again with better editing or something. But okay, so that's what I wanted to mention there. Okay, so the other thing that someone's going to download these and like shorten them, because this video probably with all my like extra asides could be, without those, it could be like 5 minutes long. But so here's the other thing. There's something you can put in your code which in a way like doesn't count. If I ever type // you can see suddenly this line is like a light gray, and I can say this will draw a green rectangle, and I can run this program and it still runs. This is what's known as a code comment. If you ever want to write annotations in your code, you might say you might do something like, to do, fix this line, I don't like the design. You could add comments to yourself in the code. Something that you might want to do later, just explanations of what different sections of the code are doing. Right now, it might feel somewhat silly to be doing this because it's so short and in a way kind of like obvious what's happening, although just these functions and numbers is somewhat cryptic. But you will thank your future self will thank your present self later if you get into the habit of writing comments into your code now. Because this inevitably will happen that you will work on a program for quite a while, you will go on vacation or do something else that has nothing to do with sitting like hunched over at your computer, because that's good for you. When you come back to it, you're not going to remember how it works or what you want to look at. And instead, but if you have all those code comments in there, it's going to allow you to kind of get back into it more easily. So get into the habit of doing that now. Okay, so I'm going to we kind of have reached the end of this kind of there's 3 videos here. One talking about coordinate systems, one kind of looking at processing and starting to write code. Now we saw a little bit about color. I'm going to give you, since this one's already 15 minutes long, I'm going to give you 2 hints of things you could look at, and maybe I'll fill them back in with and practice with another video later. There is a function called color mode that I would encourage you to look up in the reference. Here's like an exercise. Look up color mode in the reference. What are some examples? Can you change the color mode and define colors differently? One color mode that you can do in processing, I believe it's HSB. Boy, I don't have this memorized. For hue, saturation, brightness. Sometimes this is written as HSV, hue, saturation, value. But this is another way of defining color that's different than RGB. Hue being the color on the color wheel. Like, what is the hue of the color? Is it greenish blue? Is it really blue? Is it really red? Saturation being how vibrant is the color, and brightness being how bright is that color. Is it a very dark blue, a very bright blue? So one way you can play with designing colors is through hue, saturation, brightness, and you can affect that with the color mode. The other thing that I totally didn't mention at all, right? We said that fill could have one argument, which would be a grayscale color. We said that fill could have 3 arguments, which would be an RGB color. Well, here's 2 other amounts of arguments that Phil could have. Phil could have 2 arguments, which is grayscale plus transparency. It could also have 4 arguments, which is RGB, right? RGB plus transparency, often written as alpha, the alpha value. An alpha of 0 means completely transparent. An alpha of 255 means completely opaque. Now, of course, there is no such thing as real transparency. It's not that suddenly your physical screen will be see-through. It's this idea of creating the illusion of transparency. So if you draw a color with no transparency, you will see that color literally on the screen. If you draw a color with some transparency, it will look like it blends through. And I know I said I wasn't really going to go through this in great detail, but let's actually just look at this for a second. Let's make this rectangle much, much wider so we can see it. This is our, we have a green back. I'm going to give this a black background so it's a little bit easier to see. Oh, and that was not the fill. Let's have a nice bright green rectangle, which we can see right here. What if we were to draw another rectangle on top, which is red? And we'll do it at 150, 50, which with 100 pixels wide and 300 pixels high. Right? Look at that. See that red rectangle right on top of that green rectangle? Right? That's 100% opaque. But what if we give it a little bit of transparency? Right? 0 is completely transparent. 255 is completely opaque. So 127 will be right in the middle there, like 50%. If we do this, look, we can see, the camera shut off because this is like a kind of a little bit of a disaster of a day, but you can just, I'm doing the best I can. You can see now that this red here is blending with the black behind it, and the red here is blending with the green behind it. Blending being, we're seeing it's almost as if it's like a tinted lens that we put on top there. So, of course, this opens up another can of worms. There are many different ways of blending colors and this is an infinite world of stuff you can look at and do, and all of this contained in the reference and all of it in examples and through trial and error. But this should give you some beginning steps to get started. So I think you, in a way, have all the tools now. You have all the tools to make a first design. You know about the coordinate system, you know about basic shapes, and you know about color. So make yourself an alien. My little example that I always use is this like tiny little thing, person, alien, whatever, called Zug. You can see there's some ellipses, a rectangle, and some lines. But you design something, share it, send it to me. You're going to start to want to use arcs and curves and try. Doing this will sort of force you to dig into the processing reference a bit more. So I have kind of one more video in this little sequence, which is about some other advanced drawing functions in processing to do more complex shapes, which I think I'll tack on at some point. But this is sort of like your first week or time or whatever. That's your exercise. Okay, thank you. This video is way too long. I should probably cut it into a few different ones, but it just sort of is what it is right now. I'm going to go have something to eat. I need to go, have some kind of therapy or something after this as well, which maybe would be a good idea. See you later, and I hope you are enjoying yourself and your day. Bye.